Good afternoon, distinguished colleagues and guests. It's September 29, 2021, 6 p.m. Moscow time. And we're beginning the panel session for the defense of the thesis by Sergei Izmailov. Due to the fact that we have some technical problems, I have to announce the first technical break. One of the members of the board is still absent and he can't get connected. Therefore, we're waiting for him. So I announce a technical break. Should we stay? Yes, please do. And how long will the break last? So the technical break turned out to be quite short. And therefore the first technical break is over and we continue our session. So once again, we're beginning the panel session for the defense of the thesis by Sergei Izmailov. The thesis is submitted for the academic degree of Candidate of Sciences in Physics and Mathematics. The specialization is 122. Mathematical modeling, numerical methods, and program complexes. Previously, the specialization code was 051318, mathematical modeling, numerical methods, and program complexes. The Ministry of Education of the Russian Federation allowed us to change the specialization code, and the topic of the thesis is development and application of molecular dynamics and spin dynamics algorithms for characterization of polypeptide chains from disordered peptides to crystalline proteins. Under the order issued by the Academic Secretary of St. Petersburg State University, Aleksandrovich, as of June 8, 2021, number 6193/1, I, Denis Markelov, Doctor of Sciences in Physics and Mathematics, Professor of the Department of Nuclear Physics Research Methods, St. Petersburg State University, was appointed the chairperson of this dissertation board. They would also approve the candidacies of other members of the board, and let me introduce them. Nina Kasyanenko, Doctor of Sciences in Physics and Mathematics, Professor, Department of Molecular Biophysics and Polymer Physics of St. Petersburg State University. Vladislav Selivanov, Doctor of Sciences in Chemistry, Associate Professor, Senior Researcher of the Department of Organic Chemistry of the Institute of Chemistry of St. Petersburg State University. That's Stanislav. Yes, I beg your pardon for that. A bit anxious. Then Mikhail Peterhof, Doctor of Sciences in Physics and Mathematics, Associate Professor, leading researcher at the Konstantinov Institute of Nuclear Physics, Kurchatov Institute. So, that's Mikhail Peterhof. And Oksana Galdzitska, Doctor of Sciences in Physics and Mathematics, Chief Researcher, Head of the Bioinformatics and Proteome Research Laboratory of Institute of Protein Studies of the Russian Academy of Sciences. Can you see and hear us? Oksana? Yes, I'm here, I see and I hear, but I'm not Doctor of Chemical Sciences, but the Doctor of Sciences in Physics and Mathematics. Okay, I beg your pardon. Alexei Anofriev, PhD, Professor of Virginia Polytechnic Institute and State University, the United States of America. Can you see us and hear us? Yes, yes, I do. And we also have our candidate for the degree, Sergei Izmailov, and the thesis supervisor, Nikolai Skrynikov, PhD, head of the Laboratory of Biomolecular NMR, St. Petersburg State University. And I would also like to inform you that the panel session of the Dissertation Board is being recorded and broadcast on the St. Petersburg State University website, and it is also interpreted from Russian into English and vice versa. Currently we have an email address posted on the page with live broadcast of the board session, and all the listeners can submit their questions to Mr. Izmailov online. The questions regarding the thesis or scientific discussion. These questions will be forwarded to me by our technical service, and I'll read them out during the discussion. The questions must be related to the presentation and the content of the thesis, and do not forget to give your name if you submit a question. And the questions that have nothing to do to the scientific discussion and to the discussion of the thesis, to the estimates, will not be voiced. Under the order on the procedure of granting academic degrees at St. Petersburg State University, approved by local normative acts, the session of the Dissertation Board is valid, providing 2/3 of the appointed board members are present. The total number is not to be fewer than 4 people. Our Dissertation Board consists of 6 people. Everyone is with us today, including 2 members of the board who are working remotely. We have a multimedia connection with all the members of the board, as well as with our candidate for the degree, where therefore we have a quorum. And please fill out the attendance list. Our session should not last more than 2 hours, and the agenda is as follows. First comes the chairman's presentation about the documents submitted by the candidate for the degree and their conformity with the requirements. Then chairman's replies to questions, if any. 5 minutes for that. Then we're going to listen to the candidate's presentation, providing an overview and findings of the research. 15 minutes for that. And then questions to the candidate regarding the presentation. No more than 2 minutes per question. Then the candidate's replies to the questions, 10 minutes for all. Then am I going to listen to the reports on the thesis. The board members will be taking the floor in turns to provide their reviews on the thesis and questions. 10 minutes per speaker. Then the chairman's report on the thesis. Then the candidate's comments about the reports on the thesis and replies to questions. And then we're going to have an open discussion. Anyone present at the defense may state their position or ask specific questions on the thesis. 2 minutes per speaker. And at the same time, I kindly ask you to fill out the registration form and introduce yourself before I give you the floor. 9. The chairman will ask the questions submitted during the broadcast via our website. Then the candidate's replies to the questions. Then the presentation of the candidate's thesis supervisor, 5 minutes for that. Then a 5-minute discussion before the open balloting on conferring or non-conferring the academic degree. Then the discussion of the results of the defense is not broadcast, but maybe we won't need it. Then we're going to have open balloting, vote counting and recording of the results in the protocol. And then we're going to make a decision on whether to confer the academic degree or not. And finally, The candidate's closing speech. 2 minutes will be given for that. Distinguished colleagues, if there are any questions or objections on that, please do say. If there are no objections, let's proceed. But before that, I kindly ask you to turn off the sound on your mobile phones. Thank you. So let's start with the chairman's presentation. A thesis by Sergei Izmailov for the academic degree of the candidate of Sciences in Physics and Mathematics, specialization 1 to 2, mathematical modeling, numerical methods and program complexes, is titled Development and Application of Molecular Dynamics and Spin Dynamics Algorithms for Characterization of Peptide Chains from Disordered Peptides to Crystalline Proteins. The thesis was approved for the defense by the order of the Academic Secretary of St. Petersburg State University as of May 14th, 2021. Sergei Izmailov has prepared his dissertation at St. Petersburg State University, and Nikolai Skrynikov, PhD, head of the Laboratory for Biomolecular NMR of St. Petersburg State University, is the thesis supervisor. 4 published works describe the research findings. They include no papers published in peer-reviewed journals recommended by the Ministry of Education and Science, and 4 papers in publications indexed in Web of Science and Scopus. The candidate has submitted a full set of documents to the Academic Secretary, and the above-mentioned documents comply with item 12 of section 3 of the order. And all the documents provided by the candidate for the degree, as far as I'm informed, comply with the requirements and are found in the certification file. And curator of the defense, member of the dissertation of the Department of Dissertation Board Support, has all the copies. And before I give the floor to our candidate for the degree, I would like to ask the members of the board if there are any general questions to the candidate for the degree, and if there is a need to consider the whole list of documents provided by the candidate for the degree. No need for that. Okay. Sergei, then you have the floor. 13 minutes. Thank you. Today I would like to tell you about my work. The study of proteins is a comprehensive but still interesting goal. Experimental methods face objective difficulties, from preparation of samples to interpretation of the obtained results, and even when all the difficulties are over, we still get a certain projection for a set of measured values. But at the same time, in modeling, we have full information about the modeled situation, but still we need certain checkups with experiments in order to be related to the situation as it is. And studying the opportunities to study such methods is something that we've studied in our work. In the first part of my work, I studied the impact of movement of disordered proteins on the measured speed and NMR relaxation. And these proteins are important biological elements, and a large percentage of proteins is either disordered fully or has certain disordered part. For example, the histone tails in nucleosome are disordered, and post-translation modifications are mostly defining transcription. And in this work, we've chosen short peptide from 25 amino acid residues cut out from H4 histone, and it can be conditionally separated into two parts. And the first one is rich in glycine, N-terminal part, and the second one, C-terminal part, with charged amino acids. And in our modeling, we used 4 different water models, 2 3-point and 2 4-point. The ones that you see on the slide. Tip 4PD is developed for modeling of disordered proteins, by the way. And we compare the results of modeling of speeds of relaxation obtained based on the trajectory of molecular dynamics. We see R1 and cross-correlated speed eta. We see that consistence with experimental data is mostly given by tip 4PD model. And this model also shows better results when we see the distribution of radius of inertia of the peptide. And you see that conformations have more, are given more preference than in other model. In the second part of the thesis, I considered a simple algorithm for modeling of destructive ties formation in molecular dynamics. In other works, we've demonstrated that molecular dynamics is able to fold globular protein, ubiquitin, starting with a disordered conformation, but for proteins that have non-sulfide bonds have a problem because the formation of disulfide bonds should be included into the folding process. In natural conditions, the formation of disulfide bonds is carried out by several ways, and frequently we see third molecules here. For example, here you see the reaction with oxygen, and in our work we wanted to have a protocol in which the chemical part will be taken out of the parentheses, and we would be concentrated on the dynamic characteristics of protein, and we would model them as a model situation. And we've chosen guanylate, short peptide, that has 4 cysteine residues that can be connected with disulfide bonds into 3 isomers, possible isomers. And considering the developed protocol of bond formation, we managed to get the distribution on isomers that is consistent with experimental data. And in nature, guanylate is folded not independently, but in the content of proguanylate, the hormone. And proguanylate is folded before the guanylate is folded. And we launched our protocol of modeling with conformation where proguanylate body was folded already and guanylate was connected as a random chain. And during this modeling, we managed to get a structure that reproduces experimental EMR structure. And the third part of the work, we have modeling of EPR spectra from the trajectory of molecular dynamics. EPR spectroscopy is used for complicated heterogeneous systems, where other methods don't give us the necessary results. For example, molecular machines. And the source of EPR signal is unpaired electron on the label. And in our work, we use MTSL label that is connected to the protein using the sulfide bond. It is connected to cysteine residues, so that in the protein we make a point mutation on cysteine and connect MTSL label to it. And in this work, we used GB1 protein as a model. EPR spectroscopy, although it's sometimes the only accessible method for the study of such systems, the volume of information that it gives is quite negligible. Therefore, we wanted to establish an exact model that reproduces EPR spectrum in order to lay a basis for further extraction of information from EPR spectrum. That's why we adopt molecular dynamics trajectories and use equation in order to resolve the system and get a model spectrum. And in Hamiltonian, we have two members, the interaction of electron spin with magnetic field and the interaction of electron spin with the nitrogen one. And on this slide you see the comparison of model spectra with experimental spectra for free label and for two mutants. And we see that the conformity with experimental is nearly ideal. The molecular dynamics allows us to calculate not just spectra directly for the trajectories, but also for modified trajectories. We can fully turn off the protein rotation as such and get the appropriate spectrum. And you see the images over here, you see the significant difference in the spectra. And in our work we also have an algorithm for acceleration or slowdown of protein as such without the influence on the local label dynamics that takes into account anisotropy of movement. Yet another interesting peculiarity is the opportunity to model isotope or labeled marks. And here on the slide you see the modeling results compared to the experiment with two methods, direct propagation method and Redfield method. On chapter 4 we tried to use a nucleodynamic method to study slow movement in crystalline proteins. That's conformation exchange and fluctuation movement of the protein molecules. And when we think about the protein crystal, we mostly think that molecules there are not moving at all, still they have certain vibrations. And protein molecule as such has certain fluctuations, and there is dynamics in protein chains. And in this work we considered two crystalline forms of protein. They're different not just with the image and type of crystal and type of crystalline mesh, but also with different levels of occupancy of some of protein elements. For example, here 55 to 54 residues in ubiquitin are crystallized in such forms in different conformations, and we wanted to, because this fluctuation of molecules and conformation shifts in this residue happen on the scale of hundreds of microseconds, it was interesting to check whether there is some connection between them. And we developed a long trajectory for molecular dynamics and tried to detect it. On this slide you see the movement of gold molecule to this blue molecule, and at the same time you see the transition of peptide connection and the formation of salt bridge between the two residues based on two different molecules. And here you see just two molecules from the entire crystal. And also we can see the changes in the chemical orientation in the plane of peptide connection and the formation of hydrogen bond. this transition also illustrates, beg your pardon, I need to flick back. And this is illustrated during EMR experiments that show us the dispersion R1, RO. And this was done in order to implement projects. And we've created several libraries, program libraries, and we created remote runner library that allows to perform a range of tasks on remote resources, for example, via SSH, PBS, and Slurm. And we also created library Ember Runner that provides user-friendly interface for molecular dynamic protocols for the launch of trajectories and also for Ember program. And we also wrote down a library for the analysis of trajectories, and they are accessible at GitHub and PyPI. So the major results are given here in the work. I've already mentioned them shortly in my presentation, therefore there's no need to concentrate upon them. And the results were published in 4 articles, and I reported on them at 12 conferences. Thank you so much. Thank you, Sergei, for the good report. Now, I would like to ask whether anyone has questions on the report. So please. You mentioned that EPR method is the only unique method that provides certain information on the protein structure. Could you please specify what can EPR give compared to other methods? EPR is not quite an informative method, but it can be applied for systems in which other methods can't be used. For example, in order to, when we have a small size of protein, and for crystallography we need certain regular structure. And molecular machines, pores, on the one hand, we should have something large and unregular, and both high accuracy methods are not quite successful, and the EPR labeling method allows us to do that because in such systems we don't have free electrons, and that's the only signal source, this introduced label. Well, I didn't get it. What's the structural information that you get? On EPR spectrum, we have an influence of fluctuation of the label itself, and introducing the label into unknown surroundings, we can understand how blocked it is by the neighboring surroundings. So these are the simple EPR spectra that were considered in the work. Are you satisfied with the answer? The same information as EPR does. I would wanted to understand what is the structural level at it, tertiary or secondary structure, or maybe dynamics. Because right now that's not quite a popular method because it's rarely used. That's why I was surprised. the work that you did is quite a comprehensive a set of data, and there's really good in production, but what can we have here? That's a question. Usually in simple words, we have these lines entwined, and the wider the lines, the more limited movement is the limited movement of the label. The spectrum is narrower with very thin lines, and it corresponds to the labels that move more actively. Thus, you can measure the ability of this label to move in some surroundings. Yes, I got it. But there are no labels. Yes, you need to introduce them. But what about native proteins? What can be taken here? So we introduce certain mutations. I don't have original protein, but still something very close. And we did not destroy it. So these are the proposals that are generally, propositions that are generally presumed. Can you just technically, just a technical point, the microphone is far away. The members of the board, we hear them quite well, and the author, is quite far away from the microphone, therefore we don't hear him well. So is it better like that? Yes, a bit closer so that we would hear you well. Okay, I believe it's quite enough. Okay, other questions? Then I have one. In the second chapter, you offer the mechanism for the description of reaction in molecular dynamic modeling. And you also developed libraries, as far as I understood, for Amber. But will it be possible either to make some additional actions so that this mechanism would be added to GROMACS, for example, so that the person, when he launches a huge cluster and he has this reaction when two atoms get together, all these are these programs for personal use in labs on your own computers? Basically, there's no quite difficult about it. In chapter 2, we wanted to make it this way so that it is not an intrusive action on the Amber, but rather shell, this so-called integrated shell of the Amber. Therefore, the implementation of the same algorithm in any other package will not be difficult. On the other hand, that's the formation of disulfide bonds, and they need a lot of fine-tuning for this transition from the state where we don't have a bond to the state where we do have it. We should take into account all the interactions that are fading away. A similar method was used in an article that was not included into the thesis, but it was used not for the sulfide bond, but also it was based on Amber. Okay, thank you. I have but can we still integrate it? Because I know that people, they interact with these collaborations that develop codes. Maybe in the future I'll think about the opportunity not just to work in Amber or in your lab, maybe others would be able to use your achievements as well. You can maybe integrate it in the modeling package. I'll repeat. There's not difficult at all, and you don't use the Amber specificity here. The algorithms and the protocols. The protocol launches standard Amber, it analyzes the trajectory, and then it relaunches it with modified parameters. So there's no specificity of Amber, but developing for several programs at once, it's much more difficult than developing such a library for one mode. Thank you. Thank you so much. Do we have other questions on the report? I have a question on the procedure. Now I'm asking a question about the report on the thesis. What? We'll listen to questions on the thesis later, because later on I'll give the floor to the members of the board. And what's the difference here? Well, the presentation was what was mentioned before. Maybe there's some new information there. And the thesis reports are the reports that you've compiled just on the thesis. Did I answer? No. Well, I'll ask later on, because it will be hard to separate. Okay, and you'll be able to repeat then and there. No, I would like to ask a question right now. I have a question on the second part of the report. That's an interesting approach overall to use kinetic information in order to draw conclusions about the structure. So that's kinetics, and you use it to make a conclusion that this model corresponds to the structure better. So I have two questions. Whether this model is independent, first of all, and second question, so it seems that kinetics should be strongly dependent on temperature, because we should have certain dependence here. And can it actually turn out that at a small change of temperature we'll have certain change in the entire system? Basically, a temperature study was carried out for all the water models, but main emphasis was done on tip 4PD, and the discussion was based upon it because it provided more correspondence with experiment among other models. So I did just the same for all of them. And as for the fact whether we can draw conclusions on the success of this water model based on this dynamics, that's really a question that is open still. And as we have no other better options, we are making conclusions based on this information. Okay, I have a general question as well about the success of the method. You take the method of this information on kinetics, and you draw conclusions about the structure. That's an interesting approach indeed, that you believe that structure depends on kinetics. And if a water model is correct, then you have certain structures on certain layers, and it corresponds with experiment. And if not, then not. And you draw conclusions based on the structure, on mid-structure, based on the kinetic information. So I wanted to ask generally, how do you see this approach? And is it model dependence, or maybe not? How else can you check this result? EMR relaxation, I believe, is a major, if not only, method of study for disordered proteins. And if in globular proteins the same data would give us the result, so we could say that, for For example, you have a secondary or tertiary structure, and for example, if we could say that here the structure is disordered, it would be nice, but still here there is certain similarity with disordered proteins. Therefore, I believe that it's quite legit to draw conclusions based on dynamic information. Okay, thank you. Other questions? No? Okay, let's continue. Now I would like to give the floor to the members of the board with their reviews on the thesis. Do we have any external reviews? No, none. Okay. Now let's shift to our board members' speeches. As all the reviews were already published on the website, I'll offer to read just the basic points, the questions, or some negative remarks. Do we agree upon that? Okay, thank you. Now, the reviews. Nina? Yes, I beg your pardon. So we don't read this review, but rather give our impressions. Do I get it right? Well, I offer not to read the entire review, but the basic provisions. Okay. Okay, thank you so much. I want to say a few words generally on the work. I liked it a lot, and I liked it because mostly the choice of tasks was very good, and these tasks demonstrate quite relevant issues. All the systems that were considered by the author, they are interesting from the point of view of objects, and certainly a methodological approach is very interesting, the one that was developed in the work, and it demonstrated very good result and applicability. And the major contribution of this work is that the thesis had no goal to decipher certain structure. The proposals were made, propositions were made, but all these studies are done in connection with experiment. Therefore, the works that were performed regarding certain separate things, like Mikhail mentioned, regarding the structural conclusions, I still believe that the major value of this work is that modeling corresponds quite well with the experiment. Certainly, experiment is limited. It's just one, but not a combination of experimental data. But still, this modeling works are not quite effective always. These are just good proposals on what happens to our systems. But still, this correspondence with experiment is, I believe, the major value of this work. And there are new developments and good approaches to modeling, and it demonstrates that there is good correspondence, which means that there is an independent approach that can provide conclusions on the studied systems. Therefore, as for the relevance of the thesis, is quite high. On the proteins that were studied, show some dynamic peculiarities and functionality that are of particular interest. Therefore, there are no doubts that this work has scientific value. And as for the work itself, it is divided into chapters, 5 chapters, We have rather short introductions to every chapter, and the general introduction, conclusion, but maybe we'll add certain general review that would help to connect the entire thesis into a unified structure. So that's a bit of division between this divisions between these chapters. I really like this work, but from the point of view of provisions taken for the defense, conclusions that were worded, I believe that this would make the work even better. If there would be more cohesion. And as for the articles that were published, as for the conferences that the author participated in, so that was quite impressive, as well as the logics of this work. And as for the conclusion, I believe I'll read it out. Maybe it's important. A thesis by Sergei Izmailov, titled Development and Application of Molecular Dynamics and Spin Dynamics Algorithms for Characterization of Polypeptide Chains from Disordered Peptides to Crystalline Proteins, meets the requirements of the order number 6821/1, and Mr. Izmailov deserves the academic degree of the candidate of sciences in physics and mathematics and specialization, mathematical modeling, numerical methods, and program complexes. And Articles 9 and 11 of the above-mentioned order are not violated, and I would like to wish further success, further achievements in the field to Sergei, because these modeling methods are quite popular when studying biological systems. Sometimes experiments can't give us the conclusions that modeling gives us. So I wish you further success, and I like the thesis a lot. Thank you. I have all the peculiarities in my review, but it can be read online on the website. Okay, thank you. And I offer Sergei to comment on the reviews at once. There was one remark. Yes, I can even read it. There were remarks on the journal image, but I believe you can answer that. You'll correct that. And there were comments on the presenting of information. There were certain very small images on pages 199-96 that really makes reading not quite simple, and not always you can read the titles to these images. So it would be better to outline these provisions separately. That's it. Thank you. Sergei, you can answer. Yes. Thank you for the review. I agree with all the comments, and next time I'll try to avoid such mistakes. Yes, in my doctoral thesis. Okay. Stanislav, please, you have the floor. So my review, I don't read this major part. The thesis by Sergei Izmailov is dedicated to the development and testing of new algorithms of molecular dynamics and spin dynamics, using the examples of several polypeptide chains. The goal and the solutions are in correspondence with major trends of detailed study of the behavior of protein molecules and the interactions, and that's one of the goals of contemporary biology and medicine. This defines the relevance and practical value of this dissertation. And scientific novelty is described in details by the author. The development of methodology for the studying of complex molecular systems based on molecular modeling methods is certainly an important independent task of contemporary science, because it gives an opportunity for independent and adequate description of such systems using the explanation of nature and specific interactions and characteristics, and this allows us to create new medicinal products. The complexity of this problem and the discussion of drawbacks of the known methodology given in the short introduction that also gives the description of most promising fields of development. And here we have testing using experimental data, expanding the opportunities of molecular dynamics due to the introduction of additional algorithms that take into account the possible changes of characteristics of separate fragments of the system, or the use of molecular modeling in combination with quantum chemical calculations and the application of molecular dynamics to new model systems like disordered proteins and protein crystals. Thus, the dissertation work goes in line with current field of development of molecular dynamics and introduce certain contribution, and we have thematic variety and independence of each of the 5 chapters. The major factor here is the use and the development of methods of mathematical modeling of dynamic processes, and the variety of the resolved problems, and the number of magnetic resonance methods, NMR spectroscopy, relaxation in solution and in solid-state body, APR spectroscopy and relaxation that are used in the work for the testing of mathematical models offered. It just emphasizes the broad possibilities of the chosen methodological approach. So basically these are the key words that I wanted to mention, to repeat, basically. So I've given them. Now, a few words. A few important words. The personal contribution of the author to the development of the results gives us a good understanding on the character and high quality and the volume of the work that the author did personally that fully corresponds to specialization 1 to 2 to this new classification code. And the results were tested from 2015 to 2019. They were discussed on 12 conferences, and the results were published in 4 articles, and they also outlined in a PhD work. And these results are also used in 3 publications. The materials were not included in the thesis. I believe this should be taken into account as well. And as for the positive points, we should mention that the work is quite logic and concise. It has very good wording when discussing the analysis and results, and every chapter has detailed literature review with certain possible problems, with substantiation of the chosen approach and the choice of NMR parameter. And the thesis has nothing unexpected, and the critical analysis of results makes us sure that the results are quite reliable, and as well as the conclusions. And the reliability of conclusions can be supported when we consider any of the 5 chapters. And I describe every chapter here in my review. I won't read it out, but maybe 2 words. As you mentioned EPR spectroscopy, and I believe it was mentioned in the thesis as well in the end, in the conclusions of chapter 3 regarding EPR spectroscopy. So he detected cross-correlation effect, the competition of dipole-dipole, and anisotropy of chemical shift. These are 2 parameters that are well known in EMR, but we didn't have it in EPR. So from the point of view of methodology in EPR, that's also a magnetic resonance method if you compare these 2 methods, but in NMR, this Troz's spectroscopy that is based on this competition is one of the major key methods today for such studies. And if you use similar experiments with NMR, it would be nice, because I can quote what's written here in the thesis. regarding what I've already mentioned. Namely, similarity to the Tronsey effect, and it provides intriguing opportunity that the concept of Tronsey experiment will somehow be adapted to the use in impulse EPR spectroscopy. So that's connection of NMR with EPR. Certainly that's potential opportunity, but still, it sounds quite reassuring. Therefore, I hope that somehow or other the author will implement this goal later on. Now I'm going to shift to my comments and to questions. I don't have too much time. So these are inconsistencies between two languages, English and Russian, some problems with punctuation, I won't dwell upon that. And let's shift to the questions at once. So the technical remarks are quite natural for any work, for any such works, and any of such works, and certainly they will be corrected later on, as it was mentioned. And as for the questions, first of all, my question: how many colleagues did you have that helped you to perform this work? The results of which are given in chapter 3, 3 or 4, because in the English text you write about 4 colleagues, and in the Russian text you write about 3 ones. I know the answer, I've already sorted it out already, but certainly you should have the adequacy of 2 texts, because that's not some negligible point, you see. The second question, on page 112 of third chapter, associated with calculations of long MD trajectories, you write that the origin of the observed spectral EPR line, so the origin of the observed forms of spectral EPR line was detected based on the record trajectory of MD modeling with a total length of 180 microseconds. And then you write about 184 nanoseconds per day. And my question is, how long this record modeling took, and what algorithms for calculations did you use to minimize this period, because otherwise it will take years. And the third question on page 118, when listing the advantages of the proposed approach, you write that above the fact that our approach automatically takes anisotropy into account, that is important for GB1 domain, and this relation of anisotropy, here 1.39, 1.45, and my question here is as follows: how did you achieve this automatic, how do you take into account this automatic calculation of anisotropy for general diffusion GB1? And I understand that you've taken something from the literature data, and if I wanted to ask whether you have certain private checkups, and if yes, then how can anisotropy influence the results of spectral simulations? So what's the contribution of anisotropy? It's not quite high, just 1.4, and I had a chance to work with 10, for example. Here the impact is quite significant, and here it's quite negligible, and that's the general diffusion rotation, basically intramolecular error that should smooth down this anisotropy theoretically. So how was it taken into account? That's my question on anisotropy. And in conclusion, I'll read the conclusion at once, my official summary. The above-mentioned remarks are dealing with with some general issues with the format, and they don't compromise the overall high value of this thesis. That is a finished study and a good example of creative development of methodology and correct use of molecular dynamics, complex biomolecular systems for adequate description of the specific interactions and characteristics. A thesis by Sergei Izmailov, titled Development and Application of Molecular Dynamics and Spin Dynamics Algorithms for Characterization of Polypeptide Chains from Disordered Peptides to Crystalline Proteins, meets the requirements of the order as of September 1st, 2016, on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Izmailov reserves the academic degree of the candidate of sciences in physics and mathematics and specialization 1 to 2, mathematical modeling, numerical methods, and program complexes. Article 11 of the above-mentioned order is not violated. So that's my review. St. Thank you so much. Sergei, you can answer these questions. Yes, thank you so much for the review. I was pleased to read it. Certainly, I was a bit negligible, so I omitted this mentioning of Professor Peterhof. And I forgot to mention him in the Russian version of my work. As for calculation speed, indeed, this description of all the trajectories would take years. Therefore, in the work, we modeled 7 mutants of GB1 protein, and many trajectories were launched simultaneously. So we calculated them simultaneously. We organized a cluster that has 6 machines and over 20 graphic cards. Therefore, it is possible. And the time for one trajectory of the protein, mutant protein, was 3 months of uninterrupted calculation, so that's quite long-term modeling. As for automatic anisotropy consideration, in 2 implemented methods that were used, Radfield method, for example, we extract information on label movement, and in molecular dynamics, we consider how this label behaves and in an anisotropic manner, or maybe not. So we make no assumptions about the model. So use the rotation tensor to consider the correctness of the work. Therefore, that's all automatic consideration, because there are no assumptions added to the model. And as for these attempts to measure anisotropy of GB1 protein, we didn't do it, but we checked. But we checked that autocorrelation function of the axis of protein rotation give us different drop periods for correlation functions, and we got 3, 4 nanoseconds accordingly. So anisotropy of rotation in the protein is something that we have, but how strong it is and how strongly it influences the model spectrum, as you mentioned already, this label has very high mobility. Therefore, this relatively slow anisotropy will be masked by those local movements. Yes, and it won't show itself quite well in the spectrum. May I? ask an additional question. If it's so, then I believe there's no need to mention anisotropy here. No, there's no need to emphasize it here, because in this sentence you read it like like you automatically took into account something for the first time. Though I know that anisotropy is taken into account when it's strong. For example, for testosterone in the 80s, you could use inertia, a moment, and experimentally using spin mesh relaxation, you can measure it, and they got over 10, 12, or 13. So that's a specificity. So there's an impact of solvents. And these coefficients, you know, these are axially symmetric molecules that you use, and there are more complicated forms here as well. And to my mind, anisotropy is not a significant factor. Yes, not to the thesis supervisor. So do you agree with that? Yes, yes. Okay, yes. I'm satisfied with the answer. Thank you. Now let's give the floor to our next speaker. Mikhail, please, you have the floor. Well, my review is based on the traditional scheme. First of all, I give a description, and I won't read it out, but I'll shortly mention that in the work the author resolved 4 specific scientific problems. 4 scientific problems, namely he developed the methods of modeling for spin dynamics that allows to interpret the data of NMR spectroscopy of short peptides that have no permanent structure, and to model the structure of possible proteins. And also in the work, the author offered a new method of structural interpretation of EPR spectra. And yet another goal was to provide software for protein modeling for proteins with changing structure. This method is quite useful in the field, and overall it has a universal character because it allows not just to obtain dynamics of proteins with the changing structure of disulfide bonds, but it also allows to consider all the covalent transfers, and I can presume that in the future it can be used for the studies of ligands that form covalent bonds. And that's a very practical point, and from my point of view, this chapter is most relevant, practically relevant. And the 4th goal that was studied was the conformation mobility of the proteins into crystalline forms. So all these goals are quite interesting and relevant, and overall the thesis gives us a very good impression. And simultaneously, I cannot but mention that there are certain drawbacks. I'm not sure that it's associated with this particular thesis because I did not detect any provision taken for the defense, because that's traditional. That was a tradition in the old form or format, because the wording of these provisions allows us to quickly assess the contribution of the work. And right now I'm not sure whether we need these provisions or not, but that's not a question to the author, but rather, well, this meets the requirements of the order. Yes, if so, then it's okay. So above these comments about the format, I found some very strange terms like the body of protein. I've never seen such wordings before, and in English that's protein body. It sounds a bit strange. Maybe you should have chosen something different. And a lot of English loan words, but these are, some negligible comments. As for serious remarks, well, maybe that's not a remark, but rather a question. Maybe the author will be able to answer them, and I'll be happy to hear. One of the conclusions in the study of gluon and folding was that this folding happens under kinetic control. And I quote, these isomers are not advantageous. And based upon that, you draw a conclusion that the final structure is not a global minimum. The thing is that in the work, you did not study, you did not look for this global minimum at all. Therefore, I'm not sure whether you can make such conclusions about kinetic control. Maybe if you would model dynamics, maybe the situation would have changed. But so I can't dispute that. Therefore, I wanted to get an explanation here. And in modeling, how do you say it? The observed local limitations of spin labeling always stay local, and the conclusion that this dynamics is under full control of the neighboring secondary structure. I believe you can't draw such conclusions using just one example. It's strange because these are just local interactions that weakly depend on the secondary structures, and you don't give us statistics here as well. Therefore, I don't believe that this conclusion is grounded. But overall, as I've already mentioned, I liked the thesis a lot, and I believe that we are going to use these methods of protein dynamics in our work, and I'll get in touch with Sergei and learn how to do that. Therefore, I need to read this result. Yes, this last remark. The thesis by Sergei Izmailov, titled Development and Application of Molecular Dynamics and Spin Dynamics Algorithms for Characterization of Polypeptidechains from Disordered Peptides to Crystalline Proteins, meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Izmailov deserves the academic degree of the candidate of sciences in physics and mathematics and specialization 1-2, mathematical modeling, numerical methods, and program complexes. Article 11 of the above-mentioned order is not violated. So that's it. So, Sergei, you can answer the questions. Yes, thank you. As for kinetic control issue, I believe I'll agree with this comment, because we drew conclusions based on calculated energy. So maybe that's not a sufficient basis. So that's not a sufficient basis to draw some fine line some final conclusions about the kinetic control, and the literature and data, and literature data also don't give us an answer. Therefore, this remark is quite fair. And as for confirmation preferences of EPR label, I believe that's not quite quite a good wording, because in the text you have counter-argument to the widespread opinion that in the spectrum of label you see the movement of the impact of the secondary structure, and we try to dispute it, to find confirmation, studying the X-ray structures with different connection places for the label. And in fact, this proposal, and this assumption that you mentioned, it's quite ironically against my initial idea. So what did I imply? Having a spiral or a list that's around this label, these amino acids have certain combinations, and these residues have configurations that are different in alpha spiral and in beta list. So that's what I meant. Maybe you read it differently. So that's not quite a good wording. And as for terminology, these histone tails are used quite widely. Where you have tail, then this tail is connected to something. So in the text I introduced it. Therefore, just to simplify this description, I believe I can use such terms. That's it. Yes, I'm satisfied with the answers. Okay. Thank you. Now let's shift to our other members of the board. Oksana, can you give us your overview of the thesis? Yes, I turned on the microphone. What do I want to mention on this work? As for molecular dynamics, the people who are working with folding of proteins, people have mixed opinions. Some believe in this molecular dynamics method, some do not, but we understand that molecular dynamics method should go together with experimental data. And this work, certainly that's a fundamental work, and there was colossal volume of experiments, of modeling. And what I like in this work is that all the results that the author obtained, they go hand in hand with experimental data. My colleagues have already mentioned that, but I believe that's what makes this work peculiar. Because dealing with molecular modeling as such is something that we do, and that's not just that relevant, but offering some new methods and algorithms for such work, certainly this emphasizes the relevance and fundamental character of this work. And I wanted to mention that the work is based on the classical style, and what else should be mentioned, that's quite a good volume, because currently PhD theses are of less volume, and now it's given in English as well. So that's quite an impressive work, and when you write such a large book, certainly it will always have certain mistakes, misprints, and I'll dwell upon the remarks that I've had. I won't repeat what the colleagues have already mentioned. So what I didn't like in the work. In chapter 4, he used molecular dynamics to demonstrate the differences between two forms of crystal and explain the differences of occupancy that are observed in local states. But still, you didn't manage to get statistically relevant demonstrations of causation between the observed local conformation transitions and this introduced term, these fluctuations of molecules in the crystal. And other remarks are as follows. You should mention that the validity of the results is not questioned because a lot of experiments, modeling experiments were carried out, and the author chose correct objects that have quite a huge volume of experimental data in order to conduct checkups all the time. Therefore, the validity of the results is confirmed by cross-examination of numerical results and comparison with experimental data. And we see that the results of this work were actively presented at conferences, both Russian and foreign ones, and they are also published in rather good international journals with a high impact factor. And such remarks, and I've already mentioned that that's quite a significant work, and in such a work you also have misprints, English terms like oxidation folding. Once it really catches your opinion, and people, they got used to folding this English term that they just neglect this fact that we have a Russian word for it. The images are not of good quality. They are hard to read because mostly they were taken from articles. Some of them are quite small, especially in chapter 4. In the appendix. And there is this term, animated graph of torsion angle. What kind of trigonometry is that? I'm not sure because I haven't seen what this animated graph is. What kind of graph is that? Well, as for the format, you could mention a lot of comments, but that's the result of the fact that this work is quite significant, because we know that we read articles very accurately, but it's hard to read such a volume at once. And these mistakes don't compromise the high importance and high value of such works, and I've already emphasized that that's a fundamental work, and the results are not questioned. The results that the author brings for the defense, though there are no specific section dedicated to that. But still, I believe that the thesis by Sergei Izmailov, titled "The Development and Application of Molecular Dynamics and Spin Dynamics Algorithms for Characterization of Polypeptide Chains from Disordered Peptides to Crystalline Proteins," meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Izmailov deserves the academic degree of the candidate of sciences in physics and mathematics in specialization 1 to 2, mathematical modeling, numerical methods, and program complexes. And Article 11 of the above-mentioned order is not violated. And Articles 9 and 11 of the above-mentioned order are not violated. Sergei, please, you have the floor. As for the images, indeed, many of them were taken from articles, and as for the quality, here I believe we should be given an opportunity not to download more than 5 megabytes. Animated graph, that's it. Something that we see on the screen right now. This is a graph that is synchronized with the image of molecular dynamics. So that's our invention. Maybe someone did it before. And as for misprints and English loan words, indeed, I do have them, because it's hard to sort everything out, what's Russian, what's not, when you read it all the time. I believe that's it. Oksana, are you satisfied with the answer? As for this fourth remark, why you did manage to do that? Oh, okay. Well, we made a lot of different attempts here, and this vibration was of small amplitude and modeled crystals, had such a connection to molecular dynamics. Therefore, there was certain complexity in modeling here. And when we try to find the connection between different influences on the amplitudes of dynamic, here you see on the slide this interaction of K11 to D52. We carried out molecular dynamics of mutant crystal, where K11 was replaced by alanine, and we wanted to see whether we're going to have certain reflection in the amplitude of time of vibration, but we didn't get a statistically relevant answer. So these are the repeated trajectories that don't reproduce themselves. So that was a negative result that we got. Okay. Now I would like to give the floor to Aleksandrovich. The review and your remarks, if you have any. Yes, thank you. I'll be short. I was really impressed by the novelty of the work, of the topics that the author considered for topics. To my mind, each of them is interesting in their fields. It's not quite simple to combine them all in one work, and we see the amount of work that the author carried out. Once again, I emphasize the novelty, and it's really nice to read such works. And you understand that you read things that you've never heard about before. So this was the main criterion that I had. Second point that I want to emphasize is that the author already published 4 articles in good journals, and in 2 of them the author is the main author, and I believe it simplifies the goal of the commission. If we can have 2 references at the journal. And I believe that's basically the main thing. Because it's clear that articles that are published based on the thesis, they will be read by many people, by lots of people, much more people than the number of people that read the thesis fully. But articles will be read, and I believe that's one of the main points. here. And as it was already mentioned, that there is correspondence with experiment. Once again, that's an important point, and I would like to emphasize it as well. And as for remarks, certainly there are some negligible things. For example, you mentioned the histone code, but I'll question that. Whether we do have them or not, because there are mixed opinions about that. But basically, these are not significant points. The articles are published, that's what's important. And I would offer to correct those points that were mentioned, because the students that will read your thesis later on, they will get the already corrected version at once. That's the first offer that I wanted to make. And the second assumption is connected with the method of disulfide bonds. I believe that's an interesting method, and it would be nice if you would manage to move it somehow. And then you need to make some additional efforts on that. And you drew an analogy between this method and the method of continuous pH modeling. And Charlie Brooks, that's one of the leading scientists in this field. Every second lecture he starts and finishes with words that he likes to use constant pH. So I'd offer you to promote this method more, and maybe you could somehow promote this method to your readers. And I remember Martins, who delivered a report, and I asked, how can you bring your readers to an idea that you mentioned? And he said that you should use this method yourself and show that with your work. So I believe that this method is a good one, and maybe you should try to promote it. And that's it. And now I'll read the formal part. The thesis by Sergei Izmailov, titled The Development and Application of Molecular Dynamics and Spin Dynamics Algorithms for Characterization of Polypeptide Chains from Disordered Peptides to Crystalline Proteins, meets the requirement of the order and the procedure of granting academic degrees at St. Petersburg State University. And Mr. Izmailov deserves the academic degree of Candidate of Sciences in Physics and Mathematics in specialization 1 to 2 mathematical modeling, numerical methods, and program complexes. And Articles 9 and 11 are not violated. And this thesis, I believe, is quite a good one compared to the ones that I've already read, and it would be quite a good work for the US requirements. I believe that the author is has achieved very good result. So Sergei, you can answer, because there was a comment there. Maybe you should answer it, or a proposal. Well, the proposal to correct the mistakes and for the promotion of these methods in lectures, in tutorials, I believe that's a correct proposal, so I'll bear that in mind. And as for the histone code, I believe that's just an introduction to the work based on literature data. I did it based on literature data, therefore I should agree with that. Now that's my review left. I won't go along all the chapters, because colleagues have already mentioned that. I'll omit this part of my review, but I wanted to mention that the thesis indeed creates a favorable impression. It is written with a very lively language. Maybe that's the influence of these English loanwords, or maybe the articles written in English, but that added up some lively character to the text, and I like this phrase. And that starts our simulations. You know, not everyone will understand it. Certainly you refer to modeling, because simulations, that's jargonism here in this simulation environment. And there's a range of comments. I'll read them out. Two general ones. And this was already mentioned by Nina. The thesis chapters are not quite closely connected between themselves, and the conclusions from one chapter are not used in another one. Certainly the systems differ, and maybe there's nothing in between them. But in chapter 1, for example, you make a conclusion that water model tip 4PD is more suitable for modeling of peptide systems. But in other chapters you use standard tip 3P model. Maybe that's just historical development, but I believe it would be interesting to listen to the answer. The second remark, why did you use Langevin, thermostat, and Berenson barostat? To my mind, Langevin is damping the fluctuations quite slowly, and Berenstain barostate is different here. Was it a special choice that gives you certain advantages, or you just chose them like that? So this was just a choice of the modeling expert. And there were other comments on the first and second chapter. As for the first chapter, taking into account the fact that you did not consider the range up until 1 picosecond, because this modeling step was with 1 picosecond. And so it would be nice to see the estimate, whether it's enough to calculate the relaxation speed at the frequency of the tool, for example, 500 megahertz. And in this chapter, you did not consider approximation a different number of exponents. So you use different approximation methods, and it's clear that the higher the exponent, the more can be included. And as modeling gives us some part of this function, there's always this pre-exponential multiply in the time of relaxation that you have in at the place of exponent. Thus, reducing one, you increase another one, and thus we can choose a lot of answer variations that would describe our data. And I like the choice of the author that considered different options and proposed and offered to use 2 exponents. I like this option a lot. And it's clear that a lot of exponents can give us some artifacts, because exponent goes up until eternity, and it can give additional contributions. And 2 exponents, I like this choice, in fact. And it would be nice to see certain arguments on why 6 exponents are worse than 3 of them. In chapter 2, on image 2.3, you give an inertia radius, and you write that that's Hiratsa radius, but in Russian option you use inertia radius mostly. I model polymers a lot, and inertia radius, it gives us equilibrium among the first indexes, and you basically add up some temporal characteristics here, like rotation of the hole, or maybe diffusion summoned, that your system was mixed and forgot initial configuration. So I wanted to learn some additional information about this system that reached equilibrium. And the last question to chapter 2 is as follows. In this chapter, you offer a mechanism for reactions in modeling, and also you additionally offer to slow down the speed of reaction between these connections, but you don't do you give it as an option that you can include metropolysis mechanism when you have this reaction at some point or not? Does it help us to get more credible picture, or rather closer picture to the experimental values of isomers? Or maybe there's just an option that you can use further on, that you can improve later on. So I believe it requires further elaboration. And that's basically it, I believe. And now I read the last remark, that the above mentioned comments do not compromise the overall high value of the thesis, and the thesis by Sergei Izmailov meets the requirements of the order on the procedure of granting academic degrees at St. Petersburg State University, and Mr. Izmailov deserves the academic degree of the candidate of sciences in physics and mathematics in specialization 122 mathematical modeling, numerical methods, and program complexes, and Articles 9 and 11 are not violated. So that's it. Sergei, you can answer. Yes, the first question was about the coherence between the chapters and not using this type of order in other chapters. Indeed, I don't give this chronological order. I have just chosen this order for convenience. Therefore, this tip for PD was not used in chapter 2. But still, we draw conclusions, and quite recently we published an article on classrooms, and there tip for PD water was chosen as the model. As for thermostat and barostat, we were not interested in the damping of fluctuations, but we were rather more interested in the reproduction of the ensemble, and parents and thermostat does not reproduce any ensemble, therefore it can be used for certain preparatory work. And that is why we used a Langevin thermostat as the most used thermostat. And as for barostat, it's not quite clear how it influences the dynamic characteristics, whether it influences them at all. And in Amber package, we just don't have a lot of options for the choice of thermostat. Therefore, we proceed the standard way and chose barostate, Berenson barostat. Yes, beg your pardon. As for the range of 1 picosecond, in my review I gave the comparison of omedy. Maybe that's the characteristic that you should consider, but it's more reliable to consider the spectral density depending on the component with characteristic movement time. And it turns out that the contribution is proportional to tau. And for such scale of movement time, this contribution is negligible compared to the contribution of other components. Therefore, it was not taken into account. Okay. And as for the approximation, we have less exponents here indeed to get higher reliability, but when we have more opportunities for description, and you should stop somewhere, and we've chosen this option of 2 exponents with as a more reliable option, because when choosing high number of exponents than needed, we tried just to adjust the noise, and we wanted to avoid it. That's it. And as for this image and inertia radius, indeed you could have calculated the change of translation diffusion, but inertia radius here was more suitable because it can be calculated according to one short, because you don't require a certain plot here, and we may have certain additional difficulties. And for disordered peptide, calculating diffusion is not that simple as well. And it's not quite clear how to do it correctly. The last question is on the correlation of isomers with a reduced speed of reaction. How did we get it? In the original protocol, we got a correlation 37, 22, 41%, and in slowdown option, we had 55, 9, and 36%. And both options give us a discrepancy with experimental data for plus minus 15%. And this means that in this case, slowing down, the slowdown was something that we did not need. And as the thesis goes, you need just to provide the correct correlation between between the time of search of the partner for disulfide bond in order for it to comply with the experimental provisions. So there's no much difference between the delayed option and the ordinary one. I hope I answered your question. Okay, thank you. I have no more questions. And now we can switch to other items in our agenda. So I believe that everyone is satisfied with the answers. And now I can give the floor to the guests of the defense who are not in the board. Does anyone want to deliver their reviews or ask questions? No one? Okay, let's shift to the next item of our agenda, the questions submitted online. During the broadcast. Did we get any feedback? Okay, none. Then we're going to listen to the thesis supervisor. Nikolai, please, you have the floor. Yes, I turned on my microphone. You see, we're already late, and I believe everyone wants me to be short and brief, and I want to say a lot, and I believe I will do that. I would like to add up a general context to the results of Sergei due to the following fact. Sergei published a range of other articles that were the basis for the development of the thesis. And I really insisted to add up these other articles to show them on the slide as a list, to mention them, but Sergei did not agree with me. And here I want to say that there is a certain point where I believe that being too humble really is not such a positive characteristic for a scientist. And I would mention, Sergei, that we see the same way as you do at boosted thermostat and Berenson thermostat were programmed for amber. And to this end, this Sergei's name is in the list of the developers of Amber for the year 2020 and 2021, and our last models are described using our thermostat. And as for the general context, I'll go along the chapters. The first chapter was this peptide and 25 amino acids. And when we approach this work, we ask the following question. These unfolded proteins play an important role that's relevant for norm and for pathology. And we all heard about Alzheimer and Parkinson. But as for the methods to judge about what happens with an unfolded peptide, they're quite limited. And nitrogen relaxation, I believe, is the most widely used informative method. But the point here is, how can you connect these measured speeds of relaxation with dynamic modes, with the modes of movement in the unfolded protein? And here we have limited options because you have model-free models. And amplitude of movement is something that we see, but what kind of movement is that? Is it fluctuation in peptide plane or the jump of torsion angles? We don't know that. And molecular dynamics is a natural chance to give an answer here. And we had a chance to write down long trajectories for small peptides. And we've undertook this attempt and managed to classify the importance of separate forms of movement from the point of view of their contribution to spin relaxation. And once again, you can ask the following question. We have a peptide for 25 amino acids, but certain undescribed goal. And what's the biological importance of it? And Sergei, you mentioned it shortly in your speech. An article was published where we didn't just study the tip of histone, but a full-size nucleosome and a tetranucleosome, and there the results are much more interesting. And there we made a conclusion that this teal tip is positively charged, and it interacts with the DNA that is found on nucleosome, but this interaction is not of a static character, but rather a dynamic one. So it dances along the DNA surface. And basically speaking, this work was a kind of stepping stone on the way to further work where we consider the whole nucleosome. The second part, the second chapter, guanylate, also the basic provisions. You describe the basic provisions. The peptide chain is synthesized in disordered mode, then it folds, and you see the architecture, and quite frequently it goes together with the formation of disulfide bonds, and silane is just an example that we all know. We have 3 disulfide bridges there. In the repertoire of classical molecular dynamics, we don't have this effect. It's not provided for. We do have a QMMM and a reversal and so on, but these are the instruments that are not quite suitable. We can't integrate it in the algorithms of molecular dynamics in order to study the folding. And so we had such a goal, and when we worked upon it, we were moving using just our sense. Something worked, something did not, but finally we had a general concept and philosophy how it should be done. And the work was continued. Mikhail, you mentioned that there is an article, and Dmitry Luzik is the first author, and Olga Rogacheva, and Sergei is also one of the authors, and he made a good contribution to this work. And this article is dedicated to SH3 domain, to reach proline peptide, and we also made an experiment, and they get together. There is a joining here, and there is a tyrosine here, and then our logic is as follows. We have a set of parameters of power field for domain and peptide before the formation of this bond, and we have a set of parameters of this power field for the joint peptide, joined with domain. And this modeling process is organized as follows. We carry out an interpolation between the first set of parameters of the power field and the second field. And if you visualize it, it turns out that there's one connection that continuously dumps away, and there's yet another one that materializes from, and we continue modeling. There's no fluctuations of temperature, of pressure, and in this second work we formalized our approach and fully implemented this philosophy. And Sergei's contribution can't be underestimated here. Then as for crystals, there was a predecessing work or cooperation with Pond from Grenoble, and we found this fluctuation or rocking, whatever you choose, these fluctuations at several degrees, and we needed to find this characteristic limit of time. And then we paid attention to conformation dynamics, to this transfers between two types of beta rotations, and temporary scale is just the same. And it gave us a hint that maybe there is a causality here, because you had conformation transfer and molecule in the crystal repacked somehow. Therefore, you have this fluctuation. Or maybe vice versa, you have this fluctuation, the breach of salt bridge, and then the conformation transition. The local one happened on one turn. So that's a beautiful theory, but we did not find confirmation for it. Overall, I believe it can exist, and there are systems where it happens like that. And once again, this work also has a continuation together with Paul Shandy. That's the tube of tail of T5 bacteriophage, also molecular dynamics, hard body AML, and so on. And now we find ourselves in a kind of deadlock because we can't bring this data together. And it basically means that we misunderstand something about the nature of the sample. But I hope that we will understand and publish a joint work. And as for EPR, yes, I'm approaching the end. As for EPR, network style labels, they have been working for 50 years already, and currently, as Sergei described it in his report, It all started with Wayne Hubble work, and there was this enthusiasm when people said that such labels can be a kind of sun and probe for the detection of the major chain, that they serve as spirals in the folded protein, that they are fluctuating with an amplitude of 30 degrees, going across the axis, and so on, and they invented a lot. And it remained as such in the literature. And what actually happened there was not quite clear. There are Jack Fried school works, quite formal works, and to some extent they resemble model free, because somehow you can draw the amplitude, and what this amplitude means, what does it correspond to, it's unclear. And once again, we considered molecular dynamics, and to some extent we just put everything in its place. And from this point of view, I would say that this technological difficulty of this work is incredible, because this volume of these calculations and the methodology of using Lovell von Neumann equation was something that we had 15 years ago. This idea was proposed in Sweden, but we did 100 times more, and that's the real assessment. Our trajectories are 100 times longer, that's real, and we have more specified analysis. And as for Redfall theory, members of the board mentioned it, that in 1961 these ideas were mentioned. Yes, they were. But in this contemporary wording, that's matrix 23 at 23, where every element requires symbol calculations. It's unique. And Sergei programmed it all, and then numerical estimates using these trajectories of 20 microseconds. You know, that's a kind of Everest. We talk about the level of work. And Stanislav, you mentioned Trossi. Indeed, the doublets that you've shown on the slide is non-symmetric doublets. They resemble the Trossi experiment. And Ivan Podgorytov already went to work on spectrometer and already demonstrated the applicability of this Trossi principle in EPR spectroscopy. And I hope Ivan Sergeyevich listens to the broadcast, but as he is currently ill, he was unable to come. So that's a short review that I wanted to give you. And as a conclusion, I would like to dwell upon the author as a person. First of all, I wanted to mention that Sergei is quite a gifted person. And regarding this most recent EPR project, several times we had disputes, and it took hours sometimes, and those were quite significant disputes, not about technical details, but about the understanding of physics and how to interpret this physics into mathematics and into the program code. And Sergei proved to be right, and I was mistaken, and I had to say that I was really glad about that, because he saw this problem, he understood it better than I did in many cases. A second point that I wanted to mention is that he's quite industrious, so that's a combination of being gifted and industrious, and that's quite an impressive combination. And Sergei works a lot in a systemic manner, and it's always pleasant to work with him, and I wanted to mention that as well. Therefore, I believe that he deserves the academic degree of the candidate of sciences, and I thank you for the joint work. Thank you so much. Distinguished colleagues, now we have this last opportunity to ask, to voice our opinions, if anyone wants to do that. No one? Okay. Any other questions submitted online? None? Okay. Clear. Then we stop taking questions. And before finalizing, a final vote, I need to ask a question to the members of the board and to the candidate for the degree. If there are any questions or remarks about the procedure of holding our session, maybe the ones associated with remote access, I need to ask you all. Nina, no remarks? No remarks. Okay, none. Oksana? No. Alexei? No. Sergei? None. Okay. Now let's shift to our next item. That's the vote. It's 7 minutes past 8 Moscow time. Distinguished colleagues, now we have an opportunity to hold a 5-minute closed discussion. And this discussion will not be broadcast. Dear colleagues, how do you think whether we need such a session? Closed session? No need for that. No, everything is clear. Okay. Thank you. Then I ask for the list of participants. So I raise a question on the award of the academic degree of candidate of sciences in physics and mathematics and specialization 1 to 2 mathematical modeling, numerical methods and program complexes to Sergei Izmailov. Dear colleagues, we are to vote now, and I would like to remind you that the decision of the dissertation board on conferring the academic degree is positive, provided more than 50% of the board members, but not fewer than 3 people voted in favor. That's in conformity with Section 23 of the Order on the Procedure of Granting Academic Degrees at St. Petersburg State University. First of all, Professor Kasyanenko, please turn on the microphone. Yes, I believe that there is no doubt that Sergei deserves the academic degree of candidate of sciences in physics and mathematics. Professor Selvanov, yes, I vote for the award of the academic degree. Okay. Mikhail Peterhof, yes, I believe he deserves the academic degree. Oksana Galzitskaya, yes, I beg your pardon. Yes, I believe he deserves the academic degree. Okay, thank you. And okay, Alexei Anofriyev, yes, I believe he deserves the academic degree. Okay, I beg your pardon, something went wrong with the names today. And I also believe that our author deserves the award of the academic degree. Thus, distinguished colleagues and guests, I would like to announce that out of 6 participants, 6 people voted in favor, no one voted against, and no one abstained from the vote. Therefore, we award the academic degree of candidate of sciences in physics and mathematics and specialization mathematical modeling, numerical methods, and program complexes to Sergei Izmailov. Distinguished colleagues, due to the fact that our board meeting is carried out online, I would like to ask if the members of the board or Sergei have any questions on the procedure. So I need to solicit all of your answers. No? No objections? No questions? I have a remark. I would offer to introduce these provisions brought for the defense into the standard. Yes, not on this thesis, certainly, but basically, this should be discussed separately. Okay, I wanted to say that St. Petersburg State University has its own provision about the defense, and it is different from the Higher Education Commission provision, where these requirements were described. Therefore, that is the point. I believe we will add it to the protocol, and maybe this provision will be considered. And now the conclusion. I would like to thank, first of all, my academic supervisor for all these years of joint work and for help. And he said a lot of nice things about me, but I have not just positive characteristics, but bad ones as well. So I thank my academic supervisor for his patience and for the opportunity to do what we plan to do. And I would like to also thank the entire team of our lab, where I spent many of those years. That's Ivan Podkorytov, who organized this work and who helped a lot in our everyday work, and other colleagues who maybe have already left the lab but still did a lot for this work to succeed. And I would like to thank all the members of our team, and I would like to thank all the members of the board as well for reading this thesis and for providing the comments about it. And I would like to particularly thank all the resource centers that I worked with. So I would like to thank my department, my family, my friends, and those whom I forgot to thank as well. That's it. Thank you so much. Dear colleagues, here we stop the broadcasting of our session. Our board session is over. Thank you, everyone. Thank you.